Now we're going to invite Fransje to come tell us about some of the modeling that TUDelft have done, especially on some of the pilots. And there are some nice pictures, so that's always nice. So over to you, Fransje.
Good morning, everybody in the room, at home. I'm gonna explain to you what the work we've been done in Work Package 1, and especially also within the TUDelft, because this project for us was also a nice opportunity to collaborate between the urbanism and the hydraulic engineering department, and also to really explore and bring further our interdisciplinary design skills and methodologies. Because in practice, this is of course what happens within the municipalities on a daily basis, that you have to cooperate with people that are from another nature and with other skills. So I'm gonna use the Vlissingen project as an example in this. First point I need to make is that especially in the Netherlands, and I guess also in Flanders, that the construction of the landscape, or the reconstruction of the landscape into urban zones, is quite a very strict and tight-knit construction at the moment. Especially in the Netherlands, you can see that everything is controlled. The water management, hydraulic engineering, flood management is basically seen by our hydraulic engineers as their responsibility, and that's the main condition for all life in the Netherlands, so they feel the responsibility. But also behind the dike there's a tight-knit construction of the water system with this urban system as a hybrid system, and that's why it's also, if you want to change this in also the way, in the municipalities they worked in a protocolized way. There are ways how to deal with this, but to do it differently, to take nature-based solutions maybe as a new perspective is quite difficult, because the system is really aimed at the humans, so the humans first, and the human utilities and needs. So this is an interesting perspective on how can we participate again with nature. So instead of using nature as a surface, how can we participate in this again? So that was really the question. And if you look at the risk approach in the Netherlands, and I would say also in the other countries, you have the probability, raising the dike, so preventing the flood, or times the consequences. So bringing down the consequences is also a mean to bring down the risks. So this is in the sections you can see that the first 5 is really about raising the dike, and then the last 2 are about reducing the consequences and adapting your space to accommodate the flood water and without harming the people there. So the Vlissingen case, in that sense, was a bit different than the other cases, because, accepting water, is that also a nature-based solution, or is that maybe nature-based planning? As Gary just finished off with, we have this output 1, which is basically the nature-inclusive urban coastal management framework. It's now named, but this is still under revision, so the others need to accept this too. It's aimed at professionals in the municipalities, because it's showing all the governance layers of urban development, the policy layers from Europe to local, and then in the mid there's the phases of the urban project, the spatial planning decision-making model. And I'm going to explain to you, because, it's too much, that we did, I'm going to show you more explicit on this design and assess part, which is in the whole scheme, which is over here, this one. But as you can see, the longue durée, and this is where the atlas is, what Gary explained, then the urban project, making a vision, making a strategy, and then developing the project and design it is the whole part. So again, back to Vlissingen, Marije already explained the whole situation there, where they have this historical urban front, and they had this initial idea of accepting, so reducing the consequences, accepting a storm, and get water over the dike, but accommodate this. Then, of course, the question is, how much is it, and can it be accommodated in that place? I think what's also important to mention that the water will be caught in the spuikom, which is also a hydrological artifact over time. So it has been functioning as part of that space, as a part of the water system, as you can see in this first image. But at the moment, it's a green dog walking space, basically. So also, it's a green space that's very appreciated by the people around, but it also needs an upgrade. So therefore, you see the win-win situation already with, how can you combine flood management with, increasing the amenities in your city. But it does mean that you, of course, make the infrastructure project of dike becomes urban development, an area development project, and that has a very different approach and cost-benefit analysis, and this is what we really, ran into when working with the hydraulic engineers, because they can very well predict the amount of water and also how the dike needs to be raised, how much money it costs, how fast they will build it. But an area development is, of course, something entirely different, which has much more fuzziness. We wrote a paper about this. I'm not going to go into it now. So this was a sort of a first image of where would the water go. And what is important, that you work with scenarios of sea level rise and also temperature change, and that within, looking at the area, that you need this bandwidth to see how much water we can expect. So that's what we did. We took the warm scenario, which is the worst case scenario, and the moderate scenario, and looked at the area, and these are the models of Andres, looked at the area within specific also risk calculations, how much water would come over the dike. So on the left you see the warm plus, risk 1 in 100,000 years for the whole area, and on the left the same, but then the moderate scenario. You already can see the resolution of the color, the difference in the inundation that will be in that place. Then we said, it was a lot of water. Let's take a less high risk, 1 in 10,000, which is still, of course, enormous. And you can already see that the colors become lighter. So there's less water, and again, for the two scenarios, and still the whole area. And then we said, we need to only focus on the spuikom. So you also, in hydraulic engineering, in the dike management, they also look at dike part. So we're taking only this part, and how much water does actually come into the spuikom at that location. So here again in 1,000 years, so this is basically the amount of water that we started to do the project with. So in the warm plus scenario, in 10,000 years, during a storm of say 5 hours, there will be around 270,000 cubic meter water. In the moderate scenario, it will be around 80,000. So you can see there's quite a big difference. I must say that when we were making this drawing, you can see this is the spuikom which will fit 180,000 cubic meters of water. Everything was cubic, actually. Cubic millimeter that it doesn't fit, and then it needs to go elsewhere. It needs to go to the back. Well, then you run into a lot of things about pumps and how much water can go in there. That at one point we were discussing this with the engineers. I was like, let's just raise the dike because it becomes really complicated. But then, if you don't go through these complications, then you really need to, then it will never change, and that's what we want. So that's maybe another project. So here you can see the drawing of how the spuikom needs to be altered to be, it's basically sort of second dike line where you can store this, store the 180,000 cubic meter of waters, and here you can see a bit of the, the prediction of the timeline. So here, this is the final image where you can see that in the warm scenario, in 2100, there will be this 270,000 cubic meters. And in 2100, with the moderate scenario, there's 80,000 cubic meters. And the capacity is this. So with the building of this street that they're now doing, accepting the water coming over the dike, Vlissing is safe until 2070 at least. So there are still a lot of years that they could accommodate this solution. After that, at that time, we also know, maybe better, which scenario we are following. Did everybody stop eating meat? And are we really reducing the output, and also well, making the temperature not go high as fast as it is going now currently. And well, if so, then the solution is forever. If not, then you can always, of course, go into these gray solutions if necessary. So this is the image that Marije also showed, which I think is beautiful. So this street is the first street as a river in the Netherlands. So we discussed they need to invite the king, our Delta program manager, to show this, because yeah, it's the first time that we're really at the coast in this Cape Town, accepting water coming over the dike and making it into something that is appreciated and good for the town in essence, because it also adapts to climate change and rainwater nuisance. So I have a few concluding remarks that I wrote down to be sure. I still have, I don't know, I can't read it, 5 minutes, I'll be faster. I think what we really learned in cooperating with the engineers in this project is that engineers can also support this line of work. It's not as if you change from grey solutions to green solutions that you take away their work. Because this is maybe sometimes how they feel. It's not true at all, because there's, well, a lot of their knowledge that is really needed, as you can see, to also predict and understand what the water system will do. So I think that's one very big, they can change also, so that's a big conclusion. Also, nature-based solutions can really be a first step in well, flood management, seeing flood management over a longer time. So not that you have one dike that you make sure it will be safe for 100 years. No, that you will have maybe a foreshore or the other solutions that we see in the pilots. That is a step in, yeah, in being safe in the future and also increasing your amenities in the time. So I think that's a second important conclusion. I think also nature-based solutions are a perspective that can create a shared goal. So you also have to understand that for hydraulic engineers, nature-based solutions, they support their goal, which is making a town safe. While for us in urbanist departments, nature-based solutions have many more amenities. It's also about, yeah, people having a nice environment, a healthy environment, a natural environment, a biodiverse environment. So we have very different goals, and it does help you really find each other and create a shared future. I'm not showing this here, but for Southend-on-Sea, we did basically the same. And we asked the engineers in the first step to create a vision. They're never asked to create a vision. So for them, it was also like, vision. But in the end, their idea about drawing a line where you would have foreshore and then maybe also accepting consequences behind the dike for this city has been defined the vision in a very strategic way. So it was very important for them because they think, of course, in topography. And that is an additional dimension that we also need to think with in urbanism as well. So that is, I think, very important. The last point is that nature-based solutions, especially on the larger scale, is also connecting other challenges in the city. So what you can see in Vlissingen is that the street is also will also store or infiltrate rainwater, because we also suffer from rainwater storms. The street is now going to become very green. Before that was only stone. It was basically a horrible street. So you can see that you really can connect it, and that especially, yeah, nature is the basis of life. So we really need to take this as the primary condition where we want to live with. So really, well, working this out and working this up is a quite important goal. You can only really do this in coastal zones if you also make it part of the flood management. If not, then it will always be two worlds, and it will also not bring this synergy. Thank you for listening.